right, so you are welcome back. Now, the next thing again, remember from previous video, we just looked at how you can step down or step up DC voltage. In other words, let's say how you can step down DC voltage. But now, and we put in something like that. We use this as an example. And we find out that the voltage output here depends on the switching. So we said VO, this VO, okay, is duty cycle times Vs, where Vs is your source voltage. So, and this duty cycle, K, we said is T on over T. And then we said, so that we'll have that to be like that. So, and then we say, how do we get this switching? Okay, who will be here to turn this on and off? We don't have to be there. We need to put a switch. All right, we need to get something that can do that. So in other words, we are going to put a static switch here, which could be an IGBT. It could be a thyristor. All right, it could be a MOSFET. All right, and all these things, they need a signal. So what we are going to do is, for me to know the signal that will be here, if I put an IGBT, for instance, or a MOSFET there, how do I trigger, or a thyristor, how do I trigger it on? All right, that is the first thing we're going to do. So for us to do that, now we are going to have two things. The first one is we're going to have a reference, something that will generate a reference signal, and then we have also another something that will generate a carrier signal. All right, a carrier signal, okay, like that. So what I'm saying is I'm going to compare this reference signal with this carrier signal. So in other words, I need a comparator. So I can have a comparator like that. Right? Now in this comparator, so I'm going to have a reference signal, right? Vref, and I have V carrier. So I need to compare these two. Now, the outcome of this will give you the output. This output is now what will go to the switch. All right? So the switch here, as I say, we can use a thyristor. Okay, now let's see. What am I saying? So now, in this case, we're going to say, okay, from here, we're going to say whenever the reference signal Vref is more than the carrier signal, so if Vref is greater than V carrier, now we want this to output 1. All right? So in other words, whenever, if you check here, look at this. The whole of this from here to here is higher than all this point, part of the carrier. So now that means if I have like that, between this point and that point, you get 1. Okay? But here, the carrier is greater than the reference, so you get 0, like that. All right? So here, you get 1. And here, you get 0. So like that. So you see, this is 1, 0, 1, 0, 1, 0. Okay? So now, this will be now your gate signal. That's a signal that will go to the gate of the thyristor, okay? Or if you're using MOSFET, all right, to the base. Now, so now with this, this will now be used to turn this on, off, on, off, on, off. Okay, did you get it? All right? So we can give you different scenarios, and you should be able to give us sketch this and then give us the output of that. Okay. Can you see, if you look at this, here is time of on, T on. Here to there is T. So if I take this, T on, divided by T, that gives us our duty cycle. Okay. So, and when you look at that, that's our time of on, right? Time of on, which deals with the carrier also, the voltage of the carrier. So you can put that the voltage of the carrier with the voltage of the reference will give you the same thing. Because if you have this, can you see the whole of this here? Look. This has its own magnitude, and this also has its own magnitude. This is the V of the reference, and this is the V of the carrier, isn't it? All right? So if you check from here to here, that is the same thing like that. Right? From here to here is the same thing like this. So in other words, my duty cycle can still be written as taking Vref, right, divided by V carrier. So that if I take this, if you shift this up here, where Vref and V carrier are the same, right, then you have duty cycle 1. Remember what I'm saying. What I'm saying is, as you move, let's say this is, if this increases, if you increase that, then you now, this one will also increase. If you increase that, that will also increase until you get to this point. You can have full duty cycle 1. Okay? Okay. So, and remember that Vref is always, in this case, remember that this V carrier is always higher than the Vref. Okay. All right. So by the time you take this reference voltage and divide by the carrier voltage, then you can also get a duty cycle. Or you can just look at time of on, okay, divide by the total time. All right. So now, the next thing again that we are going to look at is, since we have done with this, now we're now going to look at different converters. Okay, we're going to look at buck boost, and boost. Okay, so the first we'll start with is a buck converter. Okay, so watch out for the next video. All right, thank you.